Welcome to today's episode, where we dive into the world of anode-free lithium batteries, an exciting technology that could revolutionize energy storage. Imagine a battery with no anode, offering more power, efficiency, and lighter weight. Sounds incredible, right? But how does it work, and what are the challenges holding it back? Stick around, because by the end of this video, you'll understand why this could be the future of battery technology. Check out the timestamps in the comments to jump to your favorite section, but trust me, you don't want to miss this.
Imagine if you could have electric car batteries that were lighter, cheaper, and they could go further on a single charge.
Yeah,
And that's what we're talking about here. That's the potential with this anode-free battery tech.
it is.
So, these batteries are different from like the lithium-ion ones that you're probably used to in your phone or laptop in a really fundamental way.
Right,
And that's that they don't have an anode,
right.
at least not to begin with.
Yeah, so conventional lithium-ion batteries, they have like a pre-made anode that's usually made of graphite or silicon.
Okay.
But anode-free batteries, they just start with a copper current collector.
Okay.
And the anode actually forms while you're charging it as the lithium ions
Oh, wow.
move from the cathode to that collector.
So the battery like builds itself as you charge it.
Yeah, in a way.
That's pretty wild.
Yeah. It's a pretty different way of thinking about batteries.
It is. It is. And so, what kind of impact could this have on, the whole energy storage industry? I mean, this is a pretty radical departure from how we're used to thinking about batteries.
Yeah, it has the potential to really disrupt the industry, I think.
Yeah.
We could see like lighter, longer range EVs becoming like the norm, not just like the exception because of this anode-free technology.
Yeah, and you don't have to mine for those expensive materials anymore.
Yeah, exactly. So because you're getting rid of the need for those pricey anode materials like graphite, the cost of production could go way down.
Okay.
Plus, manufacturing should get a lot simpler, so this could be a real game changer.
Yeah, and I mean, less mining for those materials, that's a win for the planet.
Definitely.
So, I mean, there's lots of potential benefits here. But you did mention earlier that no technology is perfect.
Oh, of course not.
So what are some of the challenges that scientists are running into when they're trying to make these anode-free batteries work?
Well, one of the big ones is like how the lithium actually deposits on that copper current collector.
Okay.
Ideally, you want a nice, smooth, even layer. But a lot of times what happens is the lithium forms these tiny needle-like structures called dendrites.
Dendrites. That sounds kind of harmless.
Yeah,
It's something that can cause a short circuit.
Yeah, they're a big concern because they can pierce the separator in the battery, and that can lead to a short circuit.
Right.
And obviously, that's not good for safety or the battery's lifespan.
Right.
So researchers are working really hard to find ways to prevent or at least control that dendrite growth.
So dendrites bad.
Yeah.
Got it.
Yeah.
You also mentioned this other challenge, low coulombic efficiency.
Yes.
Can you explain how that impacts the lifespan of these batteries and what are researchers doing to improve it? So for me as a consumer, I want my EV battery to last as long as possible.
Of course.
Is this something I should be worried about?
Something to keep in mind. Yeah, coulombic efficiency is basically how effectively lithium ions are transferred between the cathode and the anode during each charge and discharge cycle.
Okay.
And in anode-free batteries, some lithium gets lost during that process. It's kind of like if you have a leaky bucket that's slowly losing water,
Right.
So that means the battery's capacity fades over time, which, if you want a long-lasting device, that's definitely a concern.
Right.
So scientists are exploring different electrolyte formulations and other strategies to try and improve that coulombic efficiency and make those batteries last longer.
Okay, so it's not just about preventing short circuits.
Right.
It's about making sure the battery can hold its charge over time.
Exactly.
So are there any other challenges that they're trying to tackle?
Yeah, another big one is that lithium is very reactive.
Okay.
And it can actually degrade the electrolyte, which is that liquid component of the battery. And this decomposition can also limit the battery's lifespan. So basically, the battery slowly starts to kind of eat itself from the inside out.
Oh, okay. That's a little freaky.
Yeah.
But I'm sure, brilliant minds are working on solutions to these problems.
Absolutely.
So what are some of the, most promising approaches that they're exploring?
Well, researchers are looking at several different strategies, each one kind of targeting a specific problem. One really promising approach is to apply a protective coating to that copper current collector.
Okay.
And these coatings can encourage a more even lithium deposition, which can help prevent those dendrites from forming.
Oh, okay. So it's kind of like giving it a smoother surface to work with.
Yeah. Exactly.
Interesting. So I get the potential benefits of that, but what about the practical challenges? Like, how do they envision scaling up the production of these nano-engineered surfaces
Yeah.
to meet, like, mass market demand?
Yeah, that's a great question, and it's something that researchers are definitely working on. One approach is to try and adapt some of the existing manufacturing techniques. Okay.
From other industries, like the semiconductor industry,
Mm-hmm.
because they already have a lot of experience working with nanomaterials at scale.
Okay, so they're kind of borrowing from what's already been done.
Exactly.
Okay, cool.
All
So
right.
it sounds like we might be able to leverage some of that existing infrastructure and knowledge to kind of bring down the cost and the complexity of producing these specialized coatings.
Right. Exactly.
Awesome. So what other solutions are out there?
Another strategy is to modify the electrolyte itself.
Okay.
By tweaking the composition, scientists are trying to make it less reactive with the lithium so the battery is more stable.
So it's kind of like they're trying to find the right recipe
Yeah.
to make sure the battery doesn't like degrade too quickly.
Exactly.
Interesting. And then there's this other approach that focuses on the surface of that copper current collector.
Yeah.
You were talking about like modifying that surface at a nanoscale level, like creating little tiny grooves or structures
Right.
that can help the lithium to deposit in a more controlled manner.
So instead of a flat surface,
Yeah.
you're giving it a more structured place to land
Mhm.
so those dendrites don't pop up.
Right. Exactly.
This is really fascinating stuff. It sounds like there's a lot of potential in kind of manipulating these materials at such a tiny scale.
I mean, we're talking about like a potential revolution in energy storage here.
Yeah, it's really exciting.
It is. It's inspiring to think about the ripple effects that this research could have on our lives.
Yeah, for sure.
But, before we get too carried away,
Right.
I do want to make sure we address the fact that these anode-free batteries are still in development.
Of course, yeah.
So what are some of the key challenges that still need to be addressed before these batteries hit the mainstream?
Well, one of the main challenges is achieving that long-term cycling stability.
Okay.
Even with these improved SEIs and the dendrite suppression techniques, there's still some capacity fade that happens over time.
So they're still working on making those batteries last as long as possible.
Exactly.
What other challenges are we facing?
Well, scaling up production is another big one.
While the manufacturing process for these batteries is simpler in theory,
Right.
translating that to large-scale production is a whole other challenge.
Yeah, it's one thing to do it on a lab,
Right.
but it's another thing to mass produce them for the average consumer.
Exactly. We need to find ways to manufacture those specialized components efficiently and cost-effectively if we want to see widespread adoption.
That makes sense.
Yeah.
Are there any other roadblocks, maybe related to safety, that they're still grappling with?
Well, another area that needs more research is understanding the long-term safety implications of using lithium metal.
Okay.
While those advancements in SEIs and dendrite suppression have definitely made things safer, we need to be absolutely sure that these batteries are safe for widespread use.
Right.
Especially considering that they have the potential for much higher energy density.
Yeah, safety is definitely paramount,
It is.
especially when we're talking about batteries that are powering our cars and our homes and all of our devices.
For sure.
But it's reassuring to know that researchers are taking these concerns seriously,
Absolutely.
and they're continuing to push for improvement.
They are.
So despite all of these challenges, it really does feel like we're on the cusp of something truly revolutionary.
I think so too. The progress in this field is really remarkable.
It is.
It's a really exciting time to be following this technology, and I'm eager to see what breakthroughs come out in the next few years.
Me too. It feels like we're witnessing the dawn of a new era
Yeah,
in energy storage,
it does.
with the potential to transform everything from electric vehicles to renewable energy.
Yeah, for sure.
Thank you for watching this video. If you have any questions or doubt, feel free to drop them in the comments below. I'd be happy to help. If you found this video helpful or interesting, please consider subscribing to the channel and supporting our journey to make complex science accessible to everyone. Don't forget to like and share, and I'll see you in the next video. Thanks for tuning in.